Welcome to this explainer. Let's jump right in. Today we're doing a high-yield review of security governance and principles, pulling directly from the CISSP Chapter 1 Essentials. We are going to completely break down the complex architectural frameworks you absolutely need to know, building them from the ground up.
Here's our roadmap for today. We'll start with core security principles, move into governance and compliance, tackle the security policy hierarchy, dive into risk management frameworks, and wrap up with threat modeling and supply chain risk management.
All right, Part 1, Core Security Principles, the bedrock of protection.
The absolute anchor of our defense is the CIA triad. You know it well: confidentiality, integrity, and availability. Literally every security control is evaluated on how well it addresses these three tenets. First up, confidentiality. This is all about preventing unauthorized disclosure, keeping secret secret. Then we have integrity, which ensures that our data retains its veracity. We are protecting against unauthorized modification, meaning the data hasn't been maliciously or even accidentally changed. And finally, availability. This ensures authorized subjects get timely and uninterrupted access to the objects they need. So if a system goes down or gets hammered by a denial of service attack, that's a massive violation of availability.
Now, here's the funny thing about AAA services. It actually represents 5 crucial steps to hold subjects accountable for their actions on a system. It all starts with identification. This is simply claiming an identity, like typing in a username. Without it, the system has no starting point. Second is authentication, which tests if that claimed identity is valid, usually via a password or a hardware token. Third, we have authorization, which actually grants access based on your validated identity. Fourth is auditing, which is the programmatic tracking of what you actually do once you're inside. And finally, accounting, which takes that audit data and uses it to hold the subject accountable. If you're missing even one of these 5 elements, your security mechanism is incomplete.
To manage all these permissions without losing our minds, we rely on 2 key concepts: abstraction and security boundaries. Think of abstraction as a massive time saver. Instead of assigning permissions user by user, we collect similar elements into groups or roles and assign security controls to that collective. It's incredibly efficient, and it's exactly where personnel controls like role-based access and least privilege come into play. On the flip side, we have security boundaries. A security boundary is the line of intersection between any 2 areas with different security needs. Picture the clear division between your highly secure local area network and the absolute Wild West of the public internet. Recognizing and strictly controlling data flow across those boundaries is paramount.
Moving on to Part 2, Governance and Compliance, Overseeing the Environment. If there's one thing to take away here, it's that security governance means security is absolutely not just an IT issue. It is a core business operations issue. Security governance is the collection of practices that define and direct an organization's security efforts so they align perfectly with the broader business strategy and mission. This requires direct, active involvement from upper management. Security decisions have to be justified by actual business cases, often leveraging enterprise architectures like SABSA or compliance standards like PCI DSS to guarantee that rigorous financial and operational alignment.
But governance doesn't magically stop at your own walls, right? It extends to third-party governance. When you outsource operations, whether that's Tier 1 tech support or payroll, those vendors must stay in compliance with your security stance. This means rigorous external entity oversight and strict audits against established standards. A huge part of this is the documentation review. External auditors are going to evaluate these vendors, and if they can't provide sufficient documentation to prove compliance, it can literally result in the loss of your authorization to operate, or ATO. And without an ATO, your operations grind to a complete halt.
Navigating governance also means surviving what is essentially a global legal jungle. Organizations have to comply with varied, often overlapping regulations. You've got the GDPR in the EU and the CCPA in California, both granting massive privacy rights to consumers, like the right to know what data is collected and the right to be forgotten. In healthcare and education, laws like HIPAA and FERPA dictate data protection, while Canada uses PIPEDA. On top of that, there are intense export controls like ITAR and EAR. The flow of powerful encryption technologies and intellectual property across borders is heavily regulated, so military-grade encryption doesn't fall into the wrong hands. And guiding this entire compliance landscape is the ISC2 Code of Professional Ethics, which requires us to protect society, act honorably, provide competent service, and advance the profession.
Okay, Part 3, Security Policy Hierarchy, Structuring the Rules.
Security management planning operates on 3 very distinct timelines. First, the strategic plan.
This is your long-term, fairly stable vision looking at about 5 years. It defines the overarching security purpose. Next, we step down to the tactical plan. This is mid-term, usually covering about a year, and it details the specific projects, budgets, and acquisitions needed to hit those strategic goals. Finally, we zoom all the way into the operational plan. These are short-term, highly detailed plans updated monthly or even quarterly. They spell out the exact resource allotments and step-by-step implementation procedures, macro to micro.
To actually enact those plans, we use a top-down documentation hierarchy. Upper management kicks it off by creating security policies. These are the mandatory broad directives. Middle management then takes those policies and develops standards, which specify exact hardware and software requirements, and baselines, which dictate the absolute minimum level of security every system must meet. They also issue guidelines, which are recommended best practices, but not strictly mandatory. Finally, at the very base of the pyramid, operational managers create procedures, also known as Standard Operating Procedures or SOPs. This level is also where everyday personnel controls like acceptable use policies and NDAs live.
So, understanding the difference between due diligence and due care is absolutely critical. Due diligence is the planning phase. It's establishing the policy and the process to protect the organization. It's knowing exactly what should be done and having the blueprint ready. Due care, on the other hand, is the action phase. It is actively practicing and maintaining that plan day in and day out, doing the right action at the right time. Things like active security awareness programs, gamification, phishing simulations, establishing security champions. Those are perfect examples of due care in action. Simply put, planning is diligence, acting is care.
Next up, Part 4. Risk Management Frameworks, Standardizing Defense.
The industry offers several leading frameworks. Yeah, they can look like alphabet soup, but they are incredibly useful. COBIT maps IT security ideals directly to business objectives using 6 key principles. Then you have the NIST Cybersecurity Framework 2.0, which prescribes core operational activities: govern, identify, protect, detect, respond, and recover. We also rely on standards like FedRAMP for cloud security and the ISO 27000 series, a globally respected standard for organizational security. And let's not forget ITI, which focuses on optimizing overall IT services to actually support business growth.
For federal agencies and a lot of contractors, the NIST Risk Management Framework, or RMF, is completely mandatory. This is a disciplined, cyclical process of constantly evaluating risk. It steps through categorizing the system, selecting controls, implementing them, and assessing if they work. And that assessment, it usually requires quantitative analysis. You need to know your single loss expectancy, or SLE, which is just the asset value multiplied by the exposure factor. Take that SLE and multiply it by your annualized rate of occurrence, your ARO, and boom, you get your annualized loss expectancy, or ALE. You also use these numbers to find the actual value of a safeguard by subtracting the post-safeguard ALE and the annual cost of the safeguard from your original ALE. Also keep in mind, your residual risk is simply your total risk minus the controls gap. After you assess all that, you authorize the system and continuously monitor it over time.
The pivotal moment in that RMF cycle is the authorization to operate, or ATO. This is the official decision from an authorizing official that explicitly states the system's risk is managed to an acceptable level. To get it, management has to choose a risk response. They can mitigate, transfer, deter, avoid, or just accept the risk. Now, an ATO typically lasts for up to 5 years, but be warned, it can be instantly revoked by the authorizing official if a major security breach happens, or if you make a significant change to the system architecture.
Finally, Part 5. Threat Modeling and SCRM, Proactive Protection.
Threat modeling is how we identify, categorize, and analyze potential threats. It can be proactive, happening during the design phase, or reactive, executed after a product is already live. And we use standardized methodologies for this. STRIDE categorizes threats into spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Other popular frameworks include PASTA, VAST, DREAD, and the MITRE ATT&CK framework. Each one offers a different, structured way to quantify and categorize potential attackers and systemic vulnerabilities.
One of the best ways to expose vulnerabilities is decomposition diagramming. By visually breaking a system down into its constituent parts, the danger zones become incredibly obvious. It helps us pinpoint the exact trust boundaries where security levels change. It highlights data flow paths, shows us exactly where input points accept external data, and identifies privileged operations.
Honestly, the more you break down the system visually, the easier it is to map the threat vectors against it.
But of course, securing your own internal code is only half the battle. We also have to tackle supply chain risk management, or SCRM. Modern security absolutely demands evaluating the risks of hardware, software, and services provided by third-party vendors. You have to verify that every single link in your supply chain is reliable. This means demanding a software bill of materials, or SBOM, and verifying hardware through things like a silicon root of trust or physically unclonable functions, or PUFs. You also need to enforce business continuity metrics in your vendor agreements, establishing strict recovery time objectives, or RTO, and maximum tolerable downtime, or MTD. You just can't take chances in today's threat landscape.
As we wrap up this explainer, I want to leave you with a provocative question. Does your organization's security posture seamlessly integrate these foundational frameworks from the ground up? Really think about it. Are you actively applying the CIA triad in every single decision? Is your policy hierarchy actually aligned with business governance? I hope this breakdown has brought real clarity to these CISSP essentials and leaves you ready to apply these concepts to your exams and your daily practices. Keep learning, stay focused, and I'll catch you in the next explainer.